Now, let's maybe use an example. So this is the closest star to us. It's called Proxima Centauri. The question is, it has a parallax angle of 0.77 arc seconds. By the way, this is the largest parallax angle we've found, right? Because a larger parallax angle obviously means a smaller distance. And so just keep in mind that we've never even seen something with a parallax angle of 1 arc second. In fact, we've detected things, with lots and lots of smaller values. In fact, there's a European Space Agency satellite called Hipparcos, and that one actually, it detected things up to around 1,000 parsecs. So that's about 3,200 light years away. That was about the best they could do. So how far away is this one, though, in light years? Let's do that in light years. Well, we just have to use this equation, right? We'll go back here and say, well, the distance in parsec equals 1 over p, the parallax angle, in arc seconds. So I'll say that. So distance in parsecs equals 1 over the parallax angle, which is in arc seconds. So in this case, then, let's see. Well, I want the distance. So distance is equal to 1 over the parallax angle, so 1 over 0.77. That's pretty easy. Let me just get out my trusty calculator here. And I'll say, so 1 over 0.77. That tells me this value here. So let's say 1.30, let's just say. That'll sort of round if I want 2 decimal places. So I'll say 1.30, let's just say. So that means, this is pretty easy to do, so I get, therefore, my distance is approximately 1.30 parsec. But I want it in light years. So remember, 1 parsec equals 3.26 light years. So every 1 parsec, I have 3.26 light years. That means if I want to find my distance in light years, I have to then do, so the distance equals a 1.30 parsec. If you really want to be careful, we'll do the units here. We'll multiply that by 3.26 light years for every 1 parsec. And that's sort of, you can see where the units go. That's why I multiply by this number, because then I get the parsecs canceling out. So I have an answer of 1.30 times 3.26. So that gives me, so I'll just do this answer times 3.26. I get a distance then of 4.2, let's say, light years away. So we'll say the distance then is 4.2 light years. This is pretty darn close to the accepted value. So this is the distance to Proxima Centauri. Proxima implies close. Right, so there's this sort of Alpha Centauri, it's in the Centauri. But anyway, Proxima Centauri is the closest one. As far as we know, it's the closest star to us. And that has a distance of 4.2 light years. But remember, that means if, let's say, there was some aliens on Proxima Centauri, well, maybe not on the star, of course, it'd probably be too hot, but if they were on a planet that's orbiting that star, and if there were aliens there and we wanted to talk to them, we would send them a radio signal, which is as fast as we can send things, and it would take that signal 4.2 years to get there. So if we say hi, for example, we have to wait 4.2 years until the signal gets to them. And maybe they say, hi, how are you doing? And they send that signal to us. It takes another 4.2 years. This would be insanely slow. But, it could be done. And of course, they've tried pointing telescopes to Proxima Centauri, and we don't really hear much exciting. So if there are people there, they're certainly not speaking in frequencies that we can detect. So we don't even know if there's any planets there, or if there's even any people there, or even if there's any life there. But if there were, it would certainly be slow to talk to them. And this is the closest star. All other stars are farther and farther and farther away. We have things in them millions of light years away. Those are galaxies, for example. Or in our own galaxy, we have things that are hundreds of thousands of light years away. So, yes, space is very big. There's a lot of space between stuff, oddly enough. But I really like this method, though. If we can find stars that are close to us, this trigonometry method, this parallax method, is very clever. And it allows us to tell the distance to stars with quite high accuracy. So that's why it's the method of distance determination that has one of the lowest margins of error. which means, you know, obviously if you're a scientist, you always hope that you can find a star that's really close, because then you can tell its distance really well. As we get sort of higher up in distances, our methods are sort of more and more dodgy in that they have more and more uncertainty. So we'll have sort of plus or minus lots. And we'll see some of those in the further videos.